It is a quadrilateral. It has some special properties. The opposite sides are equal. So this side and this side are equal, so I'm going to mark those as equal. This side is equal to this side. And opposite angles are congruent. Congruent is a term that means equal. So this angle is equal to this angle. And this angle is equal to this angle, but they're not the same as these two, so I'm going to have to mark them differently. So this angle and this angle are equal. But there's one other thing that's going on here. What does the word parallel mean? Yeah, the sides, yeah, the lengths of the sides, they never cross. So this leg, this side, and this side are both parallel, and there's a way to mark that as well. Here's how you mark parallel. It's like an arrow. So this side is parallel to this side, so I'll mark those with one arrow. Okay. So this means parallel. This side is parallel to this side. So I'll mark those with two. I have to mark them differently. So if the sides, if these two sides are parallel and these two sides are parallel to one another, they have to be marked differently because they're not all parallel to each other. So a parallelogram has a lot going on there. Yeah, Daniel.
So this is square, basically four-sided, all equal parallelogram?
Basically, yeah. There's other stuff happening here too. If I draw diagonals across here, I'm going to sketch a diagonal. As best I can, not very good there, I think. If I draw diagonals here, this diagonal has a different length than this diagonal. But this piece of the diagonal is equal to this piece of the diagonal. And this piece of this diagonal is equal to this piece of this diagonal. There's other stuff happening here too with the angles, but I think we'll leave it at that for now. Okay, there's a ton of things to talk about just in this shape geometrically. All right, so that's a parallelogram. Let's talk about a rectangle next. Is everybody with me? You got it? So what makes a rectangle special? Well, that's true. Everything on here is going to have four sides. It's a quadrilateral. Okay, that's a generic term for any four-sided shape. Come on, you guys can tell. No, yeah.
Every angle is equal to each other.
All the angles are equal. And specifically, how many degrees do each angle have?
90.
Yes, 4 90-degree angles. Let's mark those in. So not only are they equal, but they're special because they're all 90 degrees. So we mark a 90-degree angle a little bit differently. Are there any sides that have the same length? Oh yeah, Daniel, go ahead.
The two shorter sides and the two longer sides are the same.
They do. So maybe we can mark this with one tick mark and mark these with 2 tick marks perhaps, something like that. Okay, good. Is there anything to say about parallel? Yeah. Oh, go ahead. Tell me what you want.
If you drew the diagonal, all the diagonals would be the same length.
Ooh, how'd you know that? Was it just?
I don't know how to explain it, but I knew it.
It just makes sense.
Yeah.
Yeah. Okay. I can buy that. You're right. The diagonals, we say they bisect each other. These diagonals bisected each other too, but they left different measurements. Here in this case, all of these parts are the same length because they bisect, but they also leave equal parts. I'll talk about why that's cool here in just a minute. There's one other thing I want to mark on here. Yeah, no. Parallel lines, right. So this side is parallel to this side. And this side is parallel to this side. It's kind of hard to mark that parallel in there with that word up on top, but they are parallel. And there's more. There is more. Dealing with these angles, we'll talk about that at another time. But we could keep marking, but I'm afraid it would just get ridiculous and you wouldn't know what it all meant. So let's leave it at that for now. What about a square? Oh, hang on, back up a second. Let's say you want to build a shed, and you want to make sure that your foundation that you're going to pour concrete is square. How do you know if the foundation, like you frame it up so you can pour the concrete inside? You guys have seen that, right? You frame it up, you've got some 2x4s and some stakes and everything. How do you measure the rectangle, assuming that you're making a rectangular shed? How do you measure it to know that if it's square in all four corners? That's easy. You measure diagonally. If this diagonal equals that diagonal, then you know that your four corners are 90-degree angles. So another way that you can use a tape measure, a rather floppy thing, right, to tell if you have right angles. Just measure across the diagonals. Okay. All right, square. This one should be simple. What's special about a square? Everything's equal. That's about it. Four equal angles, just like a rectangle. What's different than the rectangle is we have four equal sides. So all sides get the same marking. Now, not all sides are parallel. These two sides are parallel. These two are parallel, but they're different. Okay. What about diagonals? They are the same. Right, just like a rectangle. The diagonals are going to be equal. This diagonal is going to be equal to this diagonal in total length, but they also split each other in half. We call that bisecting. So this piece, and this piece, and this piece, and this piece, all from the center, are equal. The other thing that's worth mentioning, again, I'm not going to mark it here, but these four angles are also equal, where here the interior angles were not equal. At least not all four. All four of these angles are equal. Not only are they equal, they're all 90 degrees. Right, these are perpendicular. All right, so that probably is worth marking. So if I mark one angle here as 90, that means that they're all 90. Okay? If one angle in two lines, when they two cross, it means they're all 90s. So we have perpendicular diagonals, equal diagonals, gosh, all sorts of things going on. All right, everybody got that marked up? Let's go to rhombus. What is a rhombus? Yeah?
Square on the foot. Basically square, right?
No. It's kind of drawn like a square in this case. Yeah?
Like if you cut it in half, the top ones are the same.
Like if I cut it in half this way or
Other that
this way?
that way.
Okay. What do you mean the top ones are the same?
I don't know how to explain it now.
The top triangle? What? Okay. All right. Noah?
Rotated square.
But it's not necessarily a square. In this picture it looks like it. But I could also draw a rhombus that looks like this. Diamond, yes. Diamond is sort of a good way to think of this. I think of it also as a squished square. It's like you take a square and you squish it a little bit. And, yeah.
Okay, so if you cut it in half, the two top lines will be the same length.
These two?
Yes.
Okay.
As each other, the two bottom lines will be the same length as each other.
That's true. And you don't even have to cut it in half for that. But you're right. You're absolutely right. All four sides are equal like a square. What's not equal are the 4 angles. So these angles, the opposite angles, would be equal, but these 2 angles would not be equal to these 2. So here we have not 90-degree angles, but opposite angles are congruent. Congruent is a word that basically means equal for geometry. Now, if I draw diagonals on this, something else happens that's pretty cool. Because this is a squished square, the diagonals are, there's something special going on here, but they're not the same length. So this piece and this piece would be the same length, but this piece and this piece would be different. Oh, by the way, parallel, 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 parallel. Tell me what you think about that intersection of the diagonals. What does it look like to you? I know I've warned you about what it looks like, but what does it look like? It is. Yeah, just like a square, these guys meet in a 90-degree angle. And that's true no matter how squished or unsquished this squarey rhombus thing is. There is one more shape that's not drawn on here. I just want to introduce it real quick. Let's put it off over here. We'll just do the best we can to draw it. It looks kind of like this.
See, that's what I was saying if you split it in half. That's why I was saying that.
That's what you were saying about splitting it in half? What is that? It's a kite. That's right. A kite is actually a name for a shape. In a kite, just like a square or a rhombus, our diagonals meet in a 90-degree angle. Opposite angles are equal. No, they're not. Not here and here. These would be equal. But what you probably just need to know is that these 2 sides are equal and these 2 sides are equal. For now, that's probably enough. But there is a shape called a kite. And we may run across it in our problems. Okay, yeah.
The lines, like the top right line and the bottom left line parallel to each other?
No, they're not. Not in a kite. Yeah, there's nothing parallel in a kite. Which makes it interesting because it's kind of a regular shape and yet it doesn't have that parallel aspect to it. All right, let's move over here to trapezoid. We're almost done with this. Trapezoid. Trapezoid, again, a 4-sided shape. What makes a trapezoid special? Anybody know? No? What do you think's going on with these 2 sides? That's true, they're not equal, but there is something that they have in common. They are parallel. Yeah. A trapezoid has 1 pair of parallel sides. Other than that, there's really nothing else to say about a trapezoid. It has 1 pair of parallel sides. The diagonals don't do anything special. They can be kind of funky. The angles can be funky. There can be all sorts of things going on with the angles. The parallel sides could be here, or they could be here. It just depends on how it's drawn. But that takes us to a little bit more of a regular shape, an isosceles trapezoid. Now, we haven't talked about isosceles, but does anybody know what makes an isosceles triangle? Yeah. Yeah, actually, the correct definition of an isosceles triangle is at least two equal sides. It can actually have three equal sides. We oftentimes call that equilateral, but it's also an isosceles triangle. So an isosceles trapezoid is sort of an isosceles triangle, if you will. You don't have to draw this. That's had the top chopped off. Okay? So by having that top chopped off, it becomes a four-sided shape, and we have two parallel sides. But because it's isosceles, our base angles, we call these base angles, are equal. And if these two angles are equal, what if I turned it upside down? Wouldn't these also become base angles? Yeah. So these angles are also equal. The angles, the base angles, are, I'm going to introduce another new symbol. It's an equal with a squiggle. It's called congruent. They're congruent. And this is sort of the geometric version of equal. Okay? Base angles are equal. There's also some stuff going on with the diagonals. If I draw some diagonals in. Oh, there's other stuff. Hang on, back up. This side and this side are equal. The non-parallel sides are equal. The parallel sides are not equal. And the diagonals, they don't bisect one another. They don't split in half, but they do make equal parts here and here. So they end up sort of making a couple of isosceles triangles in the shape. And I think that's enough for that. That's a lot of information on a page, but it's good stuff, and it is things there. These are some things that you will want to be aware of, maybe even commit to memory, put on your half-page of notes, something like that. Okay?